Okay, so back again, I'm starting with number 13 on the Math 107 Test 3 review. You work for a consumer advocate agency and want to find the mean repair cost of a washing machine. As part of the study, you randomly select 40 repair costs. So that's our sample size, 40, large sample. Find the mean from the sample to be $100. The sample standard deviation, that's S, but I can use that for the population standard deviation, is $17.50. The reason I can use it is because we have a large sample. By the way, this is section 6.1, confidence intervals. So A, construct a 90% confidence interval for the population mean. Okay, so starting with A. 90% confident. So we either go to the negative Z side of the table at the bottom to find this value for the critical value of Z, 1.645, or you can use the formulas page. Somewhere I have this. You can use the formulas page from the chapter 5 and 6 formulas to find the critical value here. So either place. And you should have both of those things handy when you take the test 3. So we're going to use the critical value of Z, 1.645. So first thing I have to do is calculate the margin of error from the formulas page, Z sub C times sigma over the square root of n. So Z sub C, 1.645, times sigma, the standard deviation, I can use the $17.50, over the square root of n, which was 40. So again, if you're having trouble with square roots in your calculator, take the square root of 40, which is about 6.32455, write that down, and then do the calculation. If you're not having too much trouble, you can just multiply straight across. 1.645 times $17.50 divided by the square root of 40 equals, you get 4.551. So how do you round? Well, you're just going to match the sample mean. This is money, so it makes sense to call this $4.55 for the margin of error. Now we're going to go to the confidence interval formula. So the confidence interval formula, x bar minus e less than mu less than x bar plus e. The less than mu less than stays static. You're just filling in these values. So x bar, $100, minus e, we just calculated $4.55, less than mu less than x bar, $100, plus e, $4.55. So this is going to give me $95.45. Is less than mu is less than $104.55. So there's my confidence interval. In my math lab, my stat lab, they want you to put it in an interval notation like this, parentheses 95.45, comma 104.55, parentheses. That's how they have you put it in my stat lab, which is interval notation if we were to graph this inequality on the number line. Okay, so for 13B, so we're 90% confident that that's the true mean repair cost for washing machines. Not in my neighborhood, but that sounds about right. I guess maybe I have old data here, right? So in B, it says a 95% confidence interval. So for a 95% confidence interval, again, looking it up on the critical values table on the negative Z side or in the formulas page, you're going to use a critical value of 1.96. So again, we're going to calculate the margin of error. Z sub C, 1.96, times the standard deviation, sigma, which you're going to use S because we had a large sample, 1750 over the square root of the sample size, 40. So going to our calculator, 1.96 times 17.50 divided by the square root of 40 equals 6.324. So we'll call that 6.32. Let me do that again. 1.96 times 17.5 divided by the square root of 40, which gives me 5.42. Yeah, that didn't sound right to me. Sorry about that. So it's 5.42. Always check your figures here. So going to the confidence interval formula, we're going to take x bar 100 minus e 5.42 less than mu less than x bar 100 plus the e we just calculated 5.42. So 100 minus 5.42 for 2 is going to give me $94.58 is less than mu is less than $105.42. So there's my confidence interval with 95% confidence. We think that's really the true mean repair cost for washing machines. Again, in my stat lab, you're going to put this in an interval notation with parentheses. Okay. In question C, now we're going to calculate a 99% confidence interval. So the critical value of z, again, going to the, on the negative z side at the bottom or to your formulas page, we're going to use 2.575. So to calculate the margin of error, 2.575 z sub c times sigma 17.50 over the square root of n 40. So 2.575 times 17.50 divided by the square root of 40 equals $7.12. 7.125. So actually, we probably should make that $7.13 technically. 2.575 times 17.50 divided by the square root of 40. 7.125. So $7.12, $7.13. Pretty close. That's a penny difference. So we're going to take X bar $100 minus E, $7.13, less than mu, less than X bar $100, plus E, $7.13. So if we do this subtraction, we're going to get $92.87 less than mu, less than $107.13. That's off by a penny from the answer key, but it kind of depends on how many decimal places and how you calculated it. So, and also in my stat lab, you kind of have some wiggle room with the answers by a penny or two, I think, anyway, so it's okay. That would be either answer. If you use $7.12, that would be 88 cents here, 12 cents here. So in interval notation, 92.87 with the parentheses, comma, 107.13. Again, the answer key's off by a penny, but it's very close. So question D says, which interval is wider and why? So the more confidence you have in your estimate for the mean of the population, the wider your interval has to be. So if you compare the numbers here for the 3, this covers more numbers. So the 99% interval is wider. It covers more numbers, and the reason being is to have more confidence in your prediction. We have 99% confidence here. You're going to have to cover more numbers in your interval and have a wider interval. Okay, so going to number 14, also a confidence interval, and a random sample of 50 DVD players, so our sample size is 50. Out of date here, right? Because nobody uses DVD players anymore. The mean repair cost was $75. I'm going to put 2 zeros on it because we're going to be working with money here. And the standard deviation was, that's a sample standard deviation, but I'll use it for the population, $12.50. Again, I can use it for the population because we had a large sample. So first question, 90% confidence interval. So again, from z sub c, from our formulas, negative z side, or from your formulas page, you're going to use z sub c as 1.645. So calculating the margin of error, z sub c, 1.645, times the standard deviation, 12.50, divided by the square root of the sample size, 50. So 1.645 times $12.50 divided by the square root of 50, which if you can't get that to go in your calculator like that, write that as 7.0711 approximately. This is going to give you 2.907, so about $2.91. So going to the confidence interval formula, we're going to take X bar, which was $75, minus E, the margin of error, 2.91, less than mu, less than X bar, $75, plus E, the margin of error, 2.91. So putting that into our calculator, we should end up with $72.09, less than mu, less than $77.13. for our confidence interval with a 90% level of confidence. So 10% chance of being incorrect. In interval notation, parentheses 72.09, comma 77.91 with the parentheses. So that's how you would put that in interval notation. Okay. Let me grab something else here. Okay. So going to 14B. 14B says to do a, I covered up my paper here, to do a 95% confidence interval. So the critical value of Z for a 95% confidence interval we use is 1.96. So again, the margin of error, we're going to do Z sub C 1.96 times sigma, we're using $12.50. Standard deviation over the square root of the sample size, 50. So 1.96 times 12.50 divided by the square root of 50. I think I messed that up. Let me try that again. 1.96 times $12.50 divided by the square root of 50 equals 3.468. So we're going to call that 3.47 approximately. I'm checking my math here. Sorry, 3.464. So I'm going to call that 3.46. Something was bothering me about that. Okay, so we're going to take the sample mean, 75, minus E, 3.46, less than mu, less than x bar, 75, plus E, 3.46. So doing our subtraction, we're going to get $71.54 less than mu, less than $78.46. Using parentheses, 71.54 comma 78.46 is how you would put it in interval notation in MyStatLab. And one more here. C says let's do a 99% confidence interval. So our critical value for 14C for 99% confidence is 2.575. So again, first calculate the margin of error, 2.575, Z sub C times the standard deviation sigma, or S, 12.50 over the square root of the sample size, 50. So 2.575 times 12.50 divided by the square root of 50, about 7.0711, equals, it's a 4.551, so about $4.55 approximately. So we're going to take X bar, $75, minus E, 4.55, less than mu, less than X bar, $75, plus E, 4.55. So doing that subtraction, sorry, let me move that up so you can see it. And doing that subtraction, that is going to give you $70.45 less than mu, less than $79.55. So that is our confidence interval with a 99% level of confidence. So we have a 1% chance of being wrong for our true mean cost of repair for DVD players in the population. Okay. So I'm going to stop here and I'm going to pick up on my next video with number 15.